The International Space Station, ISS, employs a variety of strategies and technologies to protect itself from the threat of asteroids and other space debris. This protection is crucial because even small pieces of debris traveling at high velocities can cause significant damage to the ISS. The primary method for dealing with potential collisions is tracking and monitoring. NASA, along with other international space agencies, continuously monitors the space environment around the ISS using a network of ground-based radars and telescopes. This network, known as the Space Surveillance Network, SSN, is capable of detecting and tracking objects as small as 10 centimeters in diameter. When a piece of space debris or an asteroid is detected on a potential collision course with the ISS, a process called conjunction assessment begins. The last part of video is important, don't miss it. To watch more informative videos about space and technology, subscribe to my channel. During a conjunction assessment, the data from the SSN is analysed to predict the object's trajectory and determine the probability of a collision. If the risk of collision is deemed significant, the ISS will perform a manoeuvre to avoid the object. These manoeuvres, known as debris avoidance manoeuvres, DAMs, involve changing
the station's orbit slightly to ensure it passes a safe distance from the debris. The ISS has thrusters that can be used to perform these maneuvers, and planning a dam involves coordination between the ISS flight control team and the crew on board. The maneuvers are carefully calculated to use the least amount of fuel necessary while still ensuring the safety of the station and its inhabitants. In addition to tracking and maneuvering, the ISS is also designed with shielding to protect it from smaller debris that cannot be tracked. This shielding, known as Whipple shielding, consists of multiple layers of material designed to absorb and dissipate the energy of impacting particles. The outer layer of the shield is made of a thin sheet of aluminum, which causes the debris to break up into smaller, less harmful pieces upon impact. These smaller pieces then hit an inner layer of material, typically made of
the station's orbit slightly to ensure it passes a safe distance from the debris. The ISS has thrusters that can be used to perform these maneuvers, and planning a dam involves coordination between the ISS flight control team and the crew on board. The maneuvers are carefully calculated to use the least amount of fuel necessary, while still ensuring the safety of the station and its inhabitants. In addition to tracking and maneuvering, the ISS is also designed with shielding to protect it from smaller debris that cannot be tracked. This shielding, known as Whipple shielding, consists of multiple layers of material designed to absorb and dissipate the energy of impacting particles. The outer layer of the shield is made of a thin sheet of aluminum, which causes the debris to break up into smaller, less harmful pieces upon impact. These smaller pieces then hit an inner layer of material, typically made of Kevlar or other high-strength fabric, which absorbs the remaining energy and prevents the debris from penetrating the station's hull. Whipple shielding is effective against debris up to about 1 centimeter in diameter. The ISS also benefits from the fact that it operates in low Earth orbit, LEO, where the density of space debris is lower than in higher orbits. However, the risk is still significant, and international cooperation is crucial in managing it. The ISS partners, which include NASA, Roscosmos, JAXA, ESA, and CSA, share data and collaborate on strategies to mitigate the threat of space debris. This cooperation extends to the broader space community, with agencies working together to improve tracking technologies and develop new methods for debris removal. Efforts are also being made to reduce the creation of new space debris. International guidelines and best practices have been established to minimize the generation of debris during satellite launches and operations. These guidelines include measures such as ensuring that satellites are deorbited at the end of their operational life and designing them to break up into smaller, less harmful pieces upon re-entry. Adherence to these guidelines helps to limit the amount of new debris entering orbit, thereby reducing the overall risk to the ISS and other space assets. In recent years, there has been growing interest in active debris removal, ADR technologies, which aim to remove existing debris from orbit. Several concepts are being explored, including robotic arms, nets, harpoons, and lasers. While these technologies are still in the experimental stage, they hold promise for reducing the long-term threat of space debris. Successful implementation of ADR would significantly enhance the safety of the ISS and other spacecraft operating in LEO. Moreover, research is ongoing to develop new materials and technologies that can provide better protection against space debris. Advances in materials science, for example, could lead to the development of more effective shielding materials that are lighter and stronger than those currently in use. Additionally, improvements in propulsion technologies could enable more efficient and precise maneuvers, reducing the fuel requirements for dams and extending the operational life of the ISS. The human factor is also an essential part of the ISS's strategy for dealing with asteroids and space debris. The crew members aboard the ISS are trained to respond to potential collision threats. They participate in regular drills and simulations to practice the procedures for taking shelter in the Soyuz or Crew Dragon spacecraft, which serve as lifeboats in the event of a catastrophic impact. These drills ensure that the crew can quickly and efficiently respond to an emergency, minimizing the risk to their safety. Communication and coordination are key components of the ISS's defense strategy. The flight. Control teams on the ground maintain constant communication with the crew, providing real-time updates on the status of potential threats and the steps being taken to mitigate them. This close coordination ensures that everyone involved is aware of the situation and can respond appropriately. In conclusion, the International Space Station employs a comprehensive approach to deal with the threat of asteroids and space debris. This approach includes continuous monitoring and tracking of potential threats, performing avoidance maneuvers when necessary, utilizing advanced shielding technologies, and adhering to international guidelines to minimize the creation of new debris. Ongoing research and development efforts aim to improve these strategies further and ensure the long-term safety of the ISS and its crew. The success of these efforts relies on international cooperation, advanced technology, and the preparedness and training